Yeah, welcome again to this particular session on DWSM simulations. Let me take another color here. In this session, we will look at how to generate PXY diagram, uh, keeping temperature as constant. So this becomes isothermal, isothermal VLE, isothermal vapor liquid equilibrium. This is, in this, I think, as you all know, the system what we are working on is acetone plus methanol. This forms minimum boiling azeotrope, as discussed earlier in the sessions, and the azeotropic composition being 86.1%. It came up to around 77 some mole percent. Okay, this we have checked with even unified as well. Right now, going ahead in this. Let me erase these things here. There is a clarity. Yeah, done. Okay, now let me go to utilities, add utility, material streams, and binary phase number, and the feed stream. That is what we have to choose. In this, the compound one, you can see here, the compound one is acetone, compound two is methanol, and what is that we want to choose? We want to choose PXY diagram. So this is the PXY diagram, and rest all, temperature. Now the temperature is the constant. Now you can see temperature is constant now, and the changes pressure changes x and y is generated. Okay. So now as it is, you want to see this whole window here. Let me grab out this binary envelope window and try to see again. See, as you are able to see this, this is taken out. Slowly adjust this window so that it depends upon the version because this is very handy and very good. Okay. Now if I little bit move like this and then move this window up and down, and at the bottom, why I'm adjusting this is at the bottom here. Let me go to all these pictures here. At the bottom here, yeah, what you see here at the bottom, there is something called calculate. See, in the previous session, we came up to selection of the thermodynamic model also. That is Wilson, not Wilson actually. We have to choose the unifact model. So let me select unifact model because that is giving us the correct, as per the literature, it is actually giving us. So this is the thermodynamic package, what we have seen, property package. And now, let us say, and we are ready with for the generation of the diagram of T versus XY. And and one more thing. Okay, after we generate this, there is a graph generation and exponent data. We are not having exponent data. We are generating directly from the model. We can also see the table. Okay, so this one, this experimental data, if you do it in experiment and then you can give the data and then do some regression. Now, let us arrange all these things. I think we have understood all these things. Now, I would like to calculate. Let us print. Let's calculate. See, the curve is generated. Now, if you want to see this curve in a new window or in a maximum way, so shown in another window, this is what happens. Now, you see, this here, this is where somewhere, somewhere here it is falling. See that here the temperature is constant. Temperature is constant. You are finding azeotropic pressure. Okay, that is what is actually saying. Okay, right. So now let me remove this rather than let me remove. I think we have understood how to generate this PXY diagram. Once this PXY diagram is generated, the next step is I want to generate what is called XY, which is obtained in this particular picture. So I select this particular radio button. And then again I say And then again we say calculate. See now, this promptly calculated. Of course, you should know that every time you have to save everything. This Windows, this diagrams and all, you can actually copy and paste in your Word file for the convenience sake, for the reporting purposes and everything. What you can do. So in this video, what we have seen, generation of the isothermal VLE. What is this noise? Isothermal VLE. This is isothermal VLE. This is liquid. Liquid. We are having a liquid mixture, and for that liquid mixture, we are trying to know or generate the VLE data. Okay. So the thermodynamics point of view, you need to know the property package. Okay. Property package, and then you have to do all these things, right? Suppose in this particular uh, uh, work, we want to compare with the what you call other models, suppose Wilson model, Unipac model, or NRPL model, anything. We can actually click here and then compare. See here, Wilson is not working properly, so we should not take Wilson. Okay, see already it is giving in this particular for PXY or for let us generate PXY also and compare. See in the PXY data, I think both are almost merging. See, this is Wilson, Unified, Unified. Okay. Likewise, you can select 3 to 4 models and create a comparative data and report your observations. Okay. Thank you very much. And let us go to the next session and then understand this more. That means now the main intention is the separation of the system. But before going to the separation, we are understanding some things here with respect to this geotrophic system.